This is the last section in Chapter 9, the last test we are going to go through for hypothesis testing. And then you guys will have your test over Chapter 7, Chapter 8, and Chapter 9. Okay? Now, this is a 1 proportion Z test to test proportions, so the population proportion. So an example of a proportion would be like the proportion of full-time students to the proportion of part-time students. At CLC, maybe we have, I'm making this number up, I don't know what the actual number is, but maybe 42% of the population at CLC is full-time, whereas the other 58% is part-time, okay? So this is only for proportions, and if you recall back from Chapter 8, when we talked about confidence intervals for the proportion, we used the Z, or 1 proportion Z interval. We use the Z distribution to find our critical values. Okay, so that's why it's a Z test. It's just a 1 proportion Z test. We're still using the Z distribution here, and we're gonna use the calculator to get our p-value for our answer. Now, let's look at the example that we have there. Again, these hypothesis tests are all alike. The only difference here is how we get the p-value. Let's see, it says driver error can be listed as the cause of approximately 54% of all fatal auto accidents according to the American Automobile Association, or AAA. Only reason why I picked this problem is because my mom works at AAA. This will be like her 20th year working there or something like that. Now it says 30 randomly selected fatal accidents, so they tell us our sample size is 30. Are examined. It is determined that 14 were caused by driver error, so X is equal to 14 here. Let's see. Using alpha equals 0.005, is AAA's proportion correct? Alright, so let's go ahead and write our null hypothesis and then our alternative hypothesis. Now, AAA says driver error can be listed as the cause of approximately 54%. They're telling you that the proportion, the population proportion of accidents due to driver error is 54%. They're telling you exactly what it is. They're not saying it's less than or more than or at least than. They're telling you it is approximately 54%. So we're going to let that be an equal to sign. So our population proportion P is equal to 0.54. And right here is our claim. So the alternative hypothesis has the not equals to 0.54. This right here is a two-tailed test. We haven't done a two-tailed test yet. It is not equal to. Now, we need to come up with p hat. We actually don't need to come up with p hat because the calculator does want us to enter it in as x and n. So first let's find our alpha. Alpha, they told us, is 0.05. And since it's a not equal to sign, this is a two-tailed test. So that means if we were to draw this, what we're doing is finding the area in these two tails right there. And then we need to see, is our p-value less than our alpha value? So this is when we use 1 proportion Z test. It's located in the same spot as the other tests. So you hit stat and go over to tests, and it's option number 5. 1 proportion Z test. Hit enter. Now P naught is our null hypothesis proportion. So I'm going to put 0.54. My X value, it has to be a whole number. And then our N value is 30. And then are we doing a two-tailed test, left-tailed test, or right-tailed test? So this is what I have entered in on my calculator. And now I'm just going to go to calculate. So they gave us the p-value. They do give you a p hat value all the p hat value is x divided by 30. If you do 14 divided by 30, you get the 0.46 number. But p value is 0.4202. I'll write value into here. Value. So if I compare my p value to my alpha value, 0.05 to 0.4202, well, the p value is definitely greater than or equal to my alpha value. So I do not reject. I ran out of room. Let's see. Do not reject H naught. Do not reject the null hypothesis. All right, so that means since our claim was the null hypothesis and we didn't reject this one, we have evidence to support our claim. Okay? So let's go ahead and write our conclusion. There is enough evidence at the level of significance alpha is equal to 0.052. Now, our claim was the null hypothesis. We did not reject the null hypothesis. So we have evidence to support the claim that approximately 54% of accidents are due to driver error. So all I did was say I do or do not have enough evidence to support my claim. And then you just copy the claim. Remember to state your level of significance as well, right? So let me go through the final example. It says a billing company that collects bills for medical offices in the surrounding area claims that there is a change in the percent of bills being paid by Medicare. In the past, that percentage paid by Medicare is 30%. A study of 7,500 recent bills show that 33% of these bills are being paid by Medicare. The test the claim using a 5% level of significance. Show all 5 steps. Okay, so we've got H naught, we've got our alternative hypothesis. Alpha is equal to 5%, 0.05, and tailed tests. We got to pick left, right, or 2 tailed tests over here. Now, we're going to get the p-value. P-value equals, but they tell us our sample size, which is 7,500, and they tell us p-hat, which is 0.33. Out of those 7,500 people, 33% of them, their bills were being paid by Medicare. Okay? When we do it on the calculator, it doesn't ask for p-hat. It wants the number of people out of these 7,500 to be there instead. It wants the x value. So p-hat is just equal to x divided by n. If you just multiply both sides by n, x is equal to p-hat times n. So if we do p-hat times n, so 0.33 times 7,500, you get 2,475. Now, if you did get a decimal, you have to either round up or you have to round down. Either one, okay? You get to pick. It will produce slightly different numbers rounding up as opposed to rounding down, but that is okay. There will be very minimal error in this. So this is going to be the x value that you enter in on your calculator. Let's go ahead and fill out the rest. We need our null, our alternative, and what kind of test we're doing. So it tells us that the bills being in the past, the percentage that is paid by Medicare is 30%. It's not saying greater than, less than, at least, more than, anything like that. It told you it is 30%. So P is equal to 0.3, and that's what they're claiming. So the actual proportion P is not equal to 0.3. Here's our alternative hypothesis. So is it not equal? This is another two-tailed test. So now we just enter everything on the calculator. Use one proportion Z test since we're dealing with proportions. So go to stat, go over to test. It's option number 5. Option number 5. Hit enter. And fill out your data. So P naught is 0.3. Then X is 2,475. N is equal to 7,500. And it is a two-tailed test. You hit calculate. And we get this p-value here. 1.436. The e means times 10 to the negative 8. So 1.436 times 10 to the negative 8. That is a really tiny number. This is definitely less than 0.05, our alpha value. So we're going to reject our null hypothesis. Now in this case, our null hypothesis was our claim. I don't think we've seen one like this before. So let's go ahead and now write up our conclusion.
Hey, Daddy.
Hold on, Jordan.
Daddy.
Wait, go play.
Play slime.
So, now, remember our null hypothesis was our claim. So, we rejected our null hypothesis. If our null hypothesis was our claim and we rejected it, we don't have enough evidence to support it. So there is not enough evidence at the alpha is equal to 0.05 level of significance, LOS. I'm just shortening it so I don't have to keep writing it. So there is not enough evidence at the alpha equals 0.05 level of significance to support the claim that the proportion of bills paid by Medicare is 30%. Okay? So our claim was that it is 30%. We rejected the null hypothesis, and that's where our claim was. So we don't have enough evidence to support that claim. Again, a good way of writing these conclusions is to either have enough evidence to support your claim or not enough evidence to support your claim. Okay, there are alternative ways of writing it, but I think if I just give you one good way of writing it, and we're consistent about it, it's gonna confuse you less. Okay. So just to recap, these hypothesis tests, as you see, you got to follow the 5-step process. You get your null alternative hypothesis. From there, you state your level of significance. And then you choose either left tail, right tail, or two tail, depending on what your alternative hypothesis looks like. After that, you calculate the p-value. Here's the main difference when doing the hypothesis testing. You need to see whether you're doing it for a mean or a proportion. If you're doing it for proportion, you use one proportion Z test. If you're doing it for a mean, if you know the population standard deviation, you use Z test. If you don't know the population standard deviation, you use t-test. After you get your p-value, you make a decision to reject your null hypothesis or do not reject your null hypothesis. And then finally, you write a conclusion like this, either supporting your claim or not supporting your claim based on your decision.